Actions is the CI/CD product that GitHub has created. It's a relative newcomer in the world of CI/CD tools. Like a lot of the newcomers, it has a simple YAML configuration language. So it's really easy to use and easy to get into. It's also enabled by default in your GitHub repos. So unless your organization has turned it off, you can just use it by creating configurations for it. It has a huge marketplace of what they call actions, which are sort of like Jenkins plugins or Circle CI orbs. And these are bits of code that make it really easy to integrate complicated products into your pipeline. And we'll be using a few of those, so you'll get to see that. It's event-driven, so you can drive it off of pushes to your GitHub codebase, or pull requests, or time-based triggers, or webhooks. It's got built-in secrets management, so if you've got passwords you want to inject into your pipeline, that's built right in. And it's free for use. If you've got a free account, you actually get 2,000 free minutes per month, and that's a lot. I'll be using my own free account today. I've never run out of minutes for my own projects. Okay, so let's give it a shot. So I have cloned this repo, the Volnode Express repo. So hopefully you're on the same page as me, or maybe you're in your IDE. And all we need to do to create a workflow is add a workflow file. So I'm just going to use the GitHub editor to create a new file. And all of the workflows should be stashed in this directory. So you're going to create a directory called .github/workflows. And in here, you can create any number of workflow files. We're going to create one called builder.yaml. And we'll just get started. So give your workflow a name, and we'll call ours build and scan. And then we want to say when we want to trigger this. So we're going to trigger it on pushes. And here you could list out the specific branches that you want to trigger this on. We're just going to say for any pushes we want to do it. And pull requests. And again, you could list out branches here. Next, we're going to do jobs. So within a workflow, you can list any number of jobs. By default, all of these jobs are going to run concurrently, but you can enforce ordering on them. So we'll say build. And then, so build is the name of the job that we're going to create. And we're going to have this run on, we'll say runs on Ubuntu 20.04. And that means it's going to run an Ubuntu runner. This is a virtual machine in GitHub Actions, in the GitHub Actions cloud. And it's just a standard Ubuntu VM. It's got a lot of utilities, and it's generally got all the tools that you need for pipelines that you create, like a copy of Node and so forth. Now we're going to create steps, and these steps will all run in order. And you just list them out. The first one is going to be to check out our code. We're going to use an action called actions/checkout at v2. So when you say uses, that means to use one of the GitHub actions from the marketplace. Actions is the name of the organization that created it. And this is actually GitHub itself. Checkout is the name of the action. And at v2 is the version. And all of these are required components. So that just checks out your code into a workspace so you can start running stuff against it. Next one we want to create is to install Node.js. So we're going to install Node.js version 14, the latest copy of 14. And again, we're going to use an action for that. Actions/setup-node, also version 2. This one takes parameters or inputs And the input that we need for this one is which node version we would like. So this action just takes care of the complexities of installing Node.js and NPM and all of that stuff, which if you've worked with Node, it can be a little bit more complicated than you like. So we just do that in an action that makes it easy. And finally, we're going to install dependencies. And this one is going to just be a simple run command. So if I say run, rather than using one of the marketplace actions, I'm just running a shell command on this Ubuntu virtual machine. So I'm just going to run npm clean install, and that's going to install all of my npm dependencies. And I'm actually going to copy my baked version of this to make sure I didn't screw this up. Let's see how I did. Hey, it looks the same. All right, so check that in. I'm going to commit this file. So again, we just created builder.yaml in the .github/workflows directory. And I think Rebecca is going to post this to the chat if you didn't catch all of this, so that you can see that, post it yourself. So with that, I've committed this and the workflow file is there. And if I go over to actions, I should see that, yes, it's actually already running. So over here, it says all workflows build and scan. This is the workflow that I've set up. And within that, this is actually a list that will fill in over time of builds that it has run. So create builder.yaml is my commit message. Build and scan is the workflow that it's running. If I click into this, it'll show me the jobs within that workflow. And within this job, it's showing me the steps that it's running through. So it set up the job, it checked out the code just like we specified, installed Node.js, and now it's working on installing dependencies. And this step can take a little while. We'll let that bake. I'm pretty confident that this is going to work because I've done this a couple times. So I want to go ahead and move on to the next step because we've got a lot to do. All right, so that's GitHub Actions. Next step, we're going to add Dependabot to our code base. And so Dependabot, again, is software composition analysis, or SCA. Free service for all GitHub repos, whether it's private or public. It's enabled by default on public repositories, so you don't even have to turn it on generally. In our case, you do because we have manually turned it off in the source repository. It's easy to add to private repos, and the process that we'll walk through is exactly what you would do. And again, it finds libraries with vulnerabilities and downstream libraries from that. And when it finds them, it tells you about them, and it tells you exactly what to do to fix them. Everything that it finds is real, although if you've pulled in a library that has a vulnerability and you don't use that feature that has the vulnerability, then technically some of what it finds are false positives. However, it's good practice to just keep up to date with your libraries as best you can.
And Zach, before we jump into Dependabot, we actually got a question, which was, could you show us GitHub Actions again? How do you trigger the pipeline from actions specifically was the question.
Oh, sure. So when we entered that file and checked it in, so we created this builder.yaml workflow and checked it in. Just the check-in itself, GitHub Actions is always looking for files in this directory, .github/workflows. So when you check it in, it's just going to run automatically as long as you have said, hey, I want you to run this every time I do a push, which is what happens when you do a commit and a push. So if you're working from an IDE, you need to commit this change and push it up to your repository. If you want to, after it has run, you can click into a specific build that it already ran. And if you want to, you can rerun it just by rerunning all jobs here.
Awesome.
Does that help?
Zach. Yes.
Okay, so let's see, Dependabot. Already talked about it a little bit. Here's how you set it up. So back to our code repository in GitHub. What you want to do is click over to the security tab. And under here, you see lots of different security options. We're not going to talk about all of them. Worth a look, though. We're just interested right now in Dependabot alerts. And just going to click this button to enable Dependabot alerts. When you click in there, it turns out it needs a couple of things to be enabled, and it wants your permission to do that. So the first is dependency graph. So when you enable this feature, it's going to look for any files in your repo where you define dependencies. In our case, that's package.lock, or excuse me, package.json and package.lock.json. In a Java repo, it might be your pom.xml or your Gradle and init file. And other programming languages have the same concept. For Python, it would be requirements.txt and so forth. We want it to do that. The next is, hey, can I tell you when you've got issues? Yes. Let's turn on Dependabot alerts. And then finally, Dependabot security updates. This is the feature where when it finds problems, it's going to see if it can automatically fix them for you. And it's going to do that, or at least it's going to issue a pull request to suggest that you do that. We'll enable that too, because it's pretty cool. And I think it's safe. All right, we've enabled all of those features, and already you can see the security tab now has a badge by it. It says 5. And that's probably something you don't generally want to see on your code base. So let's check that out. Dependabot alerts, there's 5 of them. And it has already found several high severity issues in our code and the dependencies that we pull in. There's pug, code gen, and pug are high severity. Then it's found these other low severity issues as well. And what you'll find is when you click into these, some of them it's not going to be able to know how to fix it for you. And it'll just tell you, I can't update this to a non-vulnerable version. But it will tell you how to do it. So all you've got to do is upgrade by adding these to your package.json file. Also gives you some details about the issue that it found, what the patches are, what the workarounds are, if any, and some references for more reading. Other issues, like pug, it can fix for you. So it says, hey, click here to just bump pug from version 204 to 301, which will fix your problem. Again, it's also got these details on what the problem with that code is. If I click through to here, it takes us over to pull requests, where it has created this new pull request for us, and it just has done the work for us. So it's fixed package.json, and it's even gone through and run a build with that. So it's updated package.lock.json. It knows what to do there too. It's running checks right now. So that kicked off the workflow that we just built earlier called builder.yaml. And if I go into actions, you can see that it's running that. And I'm confident also that this check is going to succeed. It's going to install the dependencies. Everything's going to work fine. So I'm going to say, once this thing completes, you can just go down here. There we go. All checks have passed. npm install worked fine. We can merge that pull request. Again, it's going to go through our GitHub Actions workflow that we set up. So that's pretty slick. And then the rest of these issues under the security tab, we'll have to address manually. Now it's already taken this down to 2 because it was able to resolve all those other ones just by upgrading that one library, pug. So we'd go through and manually deal with this. We're not going to do that now. It's a little out of scope for this talk, but feel free to go through that exercise yourself. All right, that was Dependabot. Any questions on that one?
We don't have any yet, but I did just want to take a moment and pause. If people have any questions, feel free to drop those in the chat. We'll get you answers. We want to make sure everybody's following along before we move on to our next tool.
Cool. And the next one is CodeQL, which is a static application security test tool. So again, SAST is where it's a tool that looks at your code and it analyzes all of the code you've written, and it looks for patterns that indicate that you might have a vulnerability in your code. CodeQL is GitHub's product. There's other ones out there. And it operates by taking your code and sort of normalizing it into a database structure and running queries against it. And these queries are developed by researchers, and you can use CodeQL free for research and open source projects. So there's a lot of developers out there that are working on queries, looking for patterns that would indicate problems. When we add this to our GitHub repository, it's actually going to set up another GitHub Actions workflow to run it. So let's take a look at that. So we'll go back to our security tab. And this time we want to look at code scanning alerts, automatically detect common vulnerability and coding errors. Set up code scanning, and you can see that it's actually showing us a bunch of GitHub actions here. So CodeQL analysis is the top result. That's GitHub's tool. There's a bunch of other products out there that you can drop in. We'll set this one up. It's setting it up as a workflow, so this should look familiar. It's dropping a new workflow file into .github/workflows. And I'm going to go ahead and commit this right away because this tool can take a little while to run. But then I'll come back and talk about what this file is doing. So I've committed that file under actions. Since I've made a commit and essentially a push to this repo, it's running this new CodeQL workflow, as well as the original build and scan workflow that we created at the top of this talk. Going back to the code base, CodeQL analysis is the new workflow. And what it's doing is sets up a new workflow called CodeQL. It's triggered whenever you push to the main branch or do a pull request to the main branch. And it also runs on a schedule every week, sometime in the wee hours of the night, basically a cron job. So this is an example of another trigger that you can use to trigger your jobs. And the reason it does it on a schedule is that if you're not committing changes to your code base over time, the world is changing over time, and more queries for vulnerable patterns in code, those are changing. So it just wants to run every week just in case there's new queries that might find new problems in your code. So it sets up a single job, goes through, and in our case, it's running against JavaScript. It detected that our code base is JavaScript. It also works against Go, Java, Python, C#, C++. Goes through the steps, checks out the repository, initializes CodeQL, tries to auto-build your code, and if it fails at that, this is a step you might have to tweak for your own code base. But generally, it's pretty good at figuring out how to build your code. And then finally, it runs the CodeQL analysis. And more familiar things in here, you've got the CodeQL action as an action from the GitHub marketplace. Going back to actions, let's see where that's at. It's actually completed its run. And if I go to the security tab, there's now a single alert under code scanning alerts. And in here, this is the result of that CodeQL run that just happened. It found this issue, database query built from user-controlled sources. So this is an error. It's a security issue. Here's the Here's the reference for it. And so this is really nice. What it does is it says, hey, in your service/search.js file, I found an issue on line 6. And the issue I found is that this query depends on a user provided value. You can click through all this and get an understanding of what it's telling you. But just really quickly, I can tell you what it did because we wrote this. Essentially, this is trying to run a query against the database, and it's just dropping your search text right into the middle of the query, which is terrible form unless you have done some sanitization of this input, because this input is what I've produced right here. So I could say, like, I could drop some JavaScript in there and, oh, wow, it just popped up a JavaScript modal dialog for me. And that's not good form. But even worse than that, you could drop in a query. You could drop in a SQL injection attack. So you could, I'll show you an example of that one a little bit later. So anyway, it's found this result that's really cool, and it's telling you exactly what to do, and it's giving you more information about where you can read up on this issue. So that's CodeQL. Does anybody have any questions on that one before I move on?
We're happy to answer them. Keep Zach on his toes during these sessions if anyone has questions. We did get a question, which was, is it possible to ignore error from CodeQL if it is not relevant?
That is a great question. Yes, you can hit this dismiss button over here, and you can say, hey, this is just for my testing, or I don't care, or this is not really an issue.
Awesome.
Those are your sort of triage options.
And then if you mark it as a false positive, I'm assuming it won't show up again in future scans or
that's right.
Really
so
any of these.
That's right. So we've got this one badge here, and let's say we won't fix it. That one badge goes away.
Awesome.
Cool.
Perfect. All right.
All right. Let's take a look at StackHawk now. So StackHawk, again, is a commercial version of OWASP Zap, which is the most popular open source DAST scanner in the world. And the founder of that project, actually Simon Bennett, is with us at StackHawk. And it's OWASP Zap is a great product. And we actually, he pretty much full-time works on OWASP Zap. What we've done at StackHawk is we've added some wrappers around it, and we've added a platform behind it so that it's really easy to put StackHawk into a CI/CD pipeline. It's easy to instrument. It's got an easy configuration. And the platform behind it allows you to collect data from your scans that you run in StackHawk and show you over time the security profile of your application, and also share the results with your team members and triage issues with team members and assign vulnerabilities as they come in to people through Jira and receive alerts through Slack and that sort of thing. So it's pipeline-friendly automation. Free accounts are available for developers, and that's what we're going to set up in a minute. It's got a simple YAML configuration, and I hope you like it. So let's go ahead and set up a StackHawk account.
And Zach, we actually, before we dive in, got one more question on CodeQL, which was, is there a paper trail on a finding being marked as a false positive? I think it shows up in the GitHub audit log. Is that right?
Yeah, it does. You can also go into code scanning alerts and say, let's take a look at the closed ones, essentially.
Awesome.
Yep, closed as one fix 2 minutes ago.
Now back to where you were. Thank you.
Okay, StackHawk. Okay, so for this one, I want everybody to go to app.stackhawk.com. And from here, you can set up a new account. I'll sign up for a new account myself. And I'm just going to use Google. You can use GitHub. These are the easy ways to get into it. or you can use your own email account, in which case you're going to have to enter your own password and verify your email account and everything. So I'm just going to use Google, quick and easy way. I use my z@econger.com account. And if you're with me, so the first page that you get to once you've created your new account says, hey, call your organization something that you'd like. We'll call it StackHawk. And it's going to pull down your profile picture from whatever provider you used. And it tells me that I've allowed StackHawk permission to use this account. Next, select your plan. You are, of course, welcome to spend 99 bucks a month, but I'm going to choose the free developer account, and I recommend that you do too, certainly for this exercise. And then you have a choice here to scan my app, which is what we're going to do, or hit the Google firing range. And this is actually just going to load up sample data so you can see how StackHawk works. But Google firing range, if you're interested, is actually a service that Google operates in the cloud that just has tons of vulnerabilities, and it's meant to be used as a target for scanners like this. So we'll scan my application and continue. Welcome to StackHawk. So now we're going to get into this getting started flow. It's going to create an initial configuration file and kind of get us rolling quickly. So hit get started. First thing we need to do is generate an API key. So this is an API key that anytime you run a scan, you're going to need to inject into your scanner command line. I'll show you how to do that in just a second. You want to save a copy of this. This line down here is sort of telling you how you can save it to your own local file system. You can just copy this. You don't actually need to do this if you don't want to. You can always create new API keys, but this is what you would do. You just copy and paste that in. And now it has created this .hawk file, hawk.rc. I've got a bunch of them. And there's my API key. So I can just source that file if I wanted to run this from the command line. You don't need to do that. We're not going to do that today. Instead, I'm just going to copy my API key, go back over to my code repository, go to settings and secrets. And in here, I'm going to create a new repository secret. I'm going to call it hawk_API_key. I'm going to paste in my API key, and there we go. I've got a secret stored in GitHub Secrets, and I can pull that into my pipeline later. And we'll use that to pull it in so that we can run a scan and have the scanner talk back to the platform. Okay, that's generate an API key. Next step, create a new application. So we'll call this one same name as the repo, vuln node express. And risk level, this is entirely arbitrary. It's just for reporting. It doesn't affect the scan in any way. Same with the data type. I'll say unknown. But again, this is just for reporting. It doesn't actually change how the scan operates. So I'll hit next. Select an environment. Now what this is about is we expect users to run StackHawk against their apps in multiple environments. So you might have a development environment, in other words, your workstation. As you're developing your own code, you might run the scan locally. You can also do it in pre-production. That might be your CI/CD pipeline in your QA environment or staging environment. And then production, which is, of course, where your application ultimately is going to land. Although we actually don't recommend that you run the scanner in production, because this is a real scanner. It really hits your application pretty hard. So it can cause performance issues. And if it can get into your database and modify data, it might just do that. So we'll do it in pre-production. And the host that we're going to run against, again, this thing's going to run on the local host. So I will say http://localhost:3000. So localhost port 3000. Hit next. It has created my application. It shows me my application ID. So anytime I refer to this application in a configuration file, it wants me to use this application ID instead of the name of the application. That's just to keep track of it in our database. I'm going to hit download StackHawk.yaml. So it's created an initial configuration file for us. And I'm going to open that up. And here is the file that it created. So again, this is StackHawk.yaml. And this basic configuration is really just this first 8 lines. The rest of this is all a bunch of commented out stuff that sort of gives you an idea of some of the other configuration options that we have. Good to look into. Let's just concentrate on the simple case for now. So for our application ID is this thing that we just created. The environment is pre-production, and the host we're going to be targeting is localhost 3000. So take this and create a StackHawk.yaml file at the base of your repository. You can do it in your IDE. I'm just going to do it right here in GitHub. Go back to my code here. I'm going to say add a new file, create new file, right at the base of my repository called StackHawk.yaml. And I'll paste this in. So yours can look just like this. You just want to make sure you use your own application ID, not mine. Okay, I'll commit this and push it. And again, it's going to kick off my actions pipeline, but it's not going to have any real effect right now because I haven't specified in our actions workflow that we need to run StackHawk. So let's do that now. So we'll create another new file. This one is .github/workflows/ oh, actually, I'm sorry. Scratch that. I need to edit the file that we already built. So go back to your builder.yaml file, open this up in an editor, .github/workflows/builder.yaml. And we're going to add a couple of steps here. So the first step is, again, as I mentioned before, you've got to run the application and scan it as it's running. So this is going to be a simple command. And what we're going to do is just say npm run start. But if you just do this, then it's going to hang on this step because it's going to be running in the foreground and it's going to tie up your terminal. So you want to put it in the background by adding an ampersand at the end of it. You also want to detach it from the TTY by entering no hup at the beginning of it. So no hup, npm run start, ampersand. And then that'll be running in the background, detached from the terminal, ready for the next step, which is to run hawkscan. And hawkscan is going to use a GitHub action. And actually, let's search for it in the marketplace. So there's the GitHub Actions marketplace, where you can find all of these actions. And we'll search for StackHawk. And here's the StackHawk hawkscan action. It describes how to use this thing. And again, this is actually the very simplest possible step for using it. So it uses StackHawk hawkscan action at version 1.2.1 with an API key of what's in your secret stash, Hawk API key, which is what I just happened to use to store my secret. So I'm just going to copy and paste this in. a little bit of editing here. Okay, so the name is run hawkscan, uses the hawkscan action, and it pulls in our secret from secrets using this special notation, $ curly brace, secrets.hawk API key. Okay, I'll check this in, and it should kick off my new action. So it's running CodeQL again, and it's running our build and scan again. Now when we click in here into the build step, or the build job, setting up the job, it's going to install Node.js and dependencies, and then later on it's going to run the application and hawkscan. So this is going to take a little while. While we wait for that to cook, let's go back to StackHawk, and I'll show you around the place.
Maybe, Zach, before we dive in, I just want to check for questions and see if anybody has run into any hiccups between sign up and getting this into the builder.yaml. If you have, feel free to drop those in the chat.
This is just some light reading. Oh, do we have any questions?
Oh, no, I was going to say dive into StackHawk, and if any questions come up, I'll flag them with you.
Awesome. All right. So when you first log into StackHawk next time, it's going to drop you into this scans page. And in here, you're going to start to see every scan that you run start to pile up as a list with your last scan starting at the top. We'll look at that a little bit more later. You're also going to see there's this applications tab where all of your applications are listed. And for each one, like this full Node Express, if you run it in multiple environments, you'll see a card like this for each environment. So you might have pre-prod and development and so forth. As your scans start to fill in, it's going to show you the alerts that it found for your very last scan. So highs, mediums, and lows, as well as ways that you've triaged the issues that it's found. You can assign them to people, either through the StackHawk app, or you can actually integrate with Jira and assign them out to Jira tickets. You can accept the risk, or you can say, hey, I don't think that's a real issue. You can mark it as a false positive. As you do, these will count it, like if you had a high and you assigned it to somebody, your high will go from 1 to 0, and your assigned will go from 0 to 1. And that way in the future, if you want to break your build, or if you want to avoid getting alerted for that high alert, by triaging them, you're taking them out of play for alerts and for alerts. Integrations. We have a number of integrations with different CI/CD utilities. So Bamboo, AWS Code Services, Jenkins, GitLab, Spinnaker, and of course GitHub Actions. And if you click into these, it's just documentations that will get you up and running quickly with that technology. Then we have deeper integrations into Slack, so you can get notified every time you run a scan. Datadog, so that you can submit your results as events to Datadog. And we've got an upcoming integration with Microsoft Teams. And then finally, we've got project management integrations. So far, just Jira for now. But this is really handy, and I'll show you an example, actually, of a ticket that I created from another issue. So when you create tickets in Jira from StackHawk, it's really good at filling in all of the detail. So all of this is just default detail that StackHawk provided when I kicked out a ticket. So it says, hey, for this app, found this problem. Here's a description. Here's where I found it in this app in that environment, what it is, and here's a link back to the scan results so you can take a look at the details. And we'll be taking a look at details in a moment. Okay, so that's the 5-minute tour of StackHawk. If I go back here to GitHub Actions, I see that everything has run. So it ran the application, that worked. And it ran the Hawk scan against it, and that also worked. You can see in the background what it did was it's running Docker because Hawk scan comes packaged as a Docker container. Ran the container, injected the API key, and told it what file to look at. At the end of this, we've got a quick summary of results. So it says, hey, I found 3 high criticality issues, 12 mediums, 12 lows. There's a really brief rundown. And then here is a link to the actual results. And so when I click into those results, I've got a high-level view again. It says, hey, we've got Vuln Node Express, 3 highs, 12 medium, 12 low. Here's a summary of the plugins that we ran against your application. So these are different plugins. These are different types of probes that it ran. And then there's a list of the test that each plugin has. So Path Traversal actually has 15 different tests. Didn't find any problems with that. But cross-site scripting, it ran 2 tests and found 1 issue, and so forth. It found these 9 paths in my application. It's just informational. And then under findings, here's a little bit more detail about the issues that it found. So cross-site scripting reflected. It's a high criticality issue. It is new. We haven't seen this, or we haven't triaged it before. And we haven't triaged it in any of these 3 ways. If I click into this, it'll give me a deeper description of what's going on. Cross-site scripting reflected walks through a description of what this is, a link out to a cheat sheet to give you much more information about it, the paths that it found it on, and then over here on the right side is this evidence pane. So what this is telling you is that, hey, for this probe, I sent in this request, and I fed this data in. I sent these headers along with my request, and essentially I filled in this search text field with this information. And this is actually just like an HTMLification of this text. And then the response that I got was this text back, which is bad. So that's the evidence that I got. So it highlights it in red here. That's the evidence I got. And so that you can verify this yourself, you can hit this validate button, and it gives you a curl command that you can run that replicates the request that it sent in. And hopefully, if I run this, I can hit copy to clipboard. Hopefully, if I run that, I will see the same thing in my response that the scanner did. So I'm running this application locally, so I can paste that in, hit go, and in fact I do get exactly the same response. And here is that text reflected back to me. And that is bad because if you do that, and I'll go back and show you that again. If I paste that in, it's going to create a JavaScript alert. So it's running arbitrary JavaScript in my page, and that's not what I was intending for this app. So, so that's great. I can click on this and triage it. I can take actions. I can assign it. So I could assign it out to a Jira ticket if I had the Jira integration. But since I just created this account, I don't have that set up. Instead, I'll just say assigned to Zach. And then that one, if I go back to the results, it'll show me that I no longer have any new high alerts. Instead, I've got 1 assigned. So then when I run this scan again, it's going to say, hey, you've got 2 high alerts. And let's just go ahead and kick off another scan. We'll wait for that to finish, go through and look at some of these other ones. SQL injection. So this is really a big deal. This is saying that, hey, when I tried to enter some search text, I saw that, basically a lot of times what will happen is it'll send in a math equation and it finds that it gets the math equation solved for it in return. So this is a real issue that this code has, and I can never forget exactly how to recreate it. So I'm going to go back here. We've got it specified in the README here. If I do this search, if I do this specially crafted search, what it's going to do is it injects this SQL command into my search text. And it's going to pull all of the information from the user table, which is definitely not, what you want to happen in your application. So I'll inject that in. And you can see that it has printed out my usernames, including my admin's password. Now, this is a fake result, obviously, but it illustrates the point that I was able to jump out from the table from the SQL table that this search field is supposed to look at. I've jumped out to the user table and I've pulled some results from that. So that is a real issue. And CodeQL found that. Actually, CodeQL did not find that. It found the reflected issue, but it didn't find the SQL injection issue. StackHawk found it. StackHawk also found anti-CSRF token scanner. So this is indicating that we don't have a CSRF token. We should be injecting a CSRF token here that is a randomized token that makes sure that this search request actually came from the same browser that pulled up the search request box. Other ones like HTTP only site. Now this is one that we could probably mark as a false positive because in production we'd run it under HTTPS, but in our testing we just ran it HTTP. But it is a real issue that it found in this particular instance of the code. So that's StackHawk. And I think that's about it. Like to go recap, let's take a look at all of the things that we enabled in this repository. So we turned on Dependabot alerts, and that was pretty simple. Turned on code scanning alerts using CodeQL, which took the form of another GitHub Actions workflow. In our GitHub Actions workflow that we set up, we just set up a simple workflow that operates on every push and pull request. It checks out our code, installs Node.js, installs dependencies, runs the app, and runs HawkScan against it. And I think that's about what I have for you today. Does anybody have any questions about what we've gone over? Is there anything else you'd like to see in here?
Or has anyone ran into some troubles while they're scanning and are looking for some help troubleshooting? We're happy to help with anything that came up along the way. Well, Zach, I know one question we get quite often is, what if I have an API that I'm trying to scan for vulnerabilities? Can StackHawk help me with that?
Yes. Yeah, so if you go to docs.stackhawk, got all of our documentation up there for public consumption. And so we have a lot of different types of applications that we scan. And if you have an open API specification for your API, then that's the best way to feed paths to HawkScan. So you can, if your application actually hosts it, and you can point to the URL for it, we can use that. If you have it exported as a file, we can look at that as well. We also work with GraphQL applications. So what you can do is point it to your GraphQL endpoint. And this is kind of a differentiator for StackHawk as well. We've got a really good spider for GraphQL configurations. If you've got a SOAP API, we can hit those as well. And if you have an authenticated API, we've got a whole section on authentication because everybody does authentication differently, of course, but we've we've set it up so that you can hit any kind of authenticated endpoint. We haven't found an authentication method that hasn't worked yet. But if you find one, let us know and we'll work on that one as well. So we can handle like form authentication, JWT token authentication, external third-party token authentication, and so forth. So we've got all these guides in here to walk through examples of how you might do that.
Yes, and we'll actually be doing a webinar workshop at the end of the month on authenticated scanning specifically. So keep an eye out for news around that. That should be a really great session where we'll go over the 3 different most common types of authenticated scanning and how you can be successful in DAST scanning against those applications. All right. So we did get a question, Zach, which is on private repos, is any code sent to your servers?
No code is sent to StackHawk servers. No, just the results of the scans.
The results of the scan. So how would you be able to tell a little bit more detail around how that works, just so people know from a security perspective what that looks like?
Sure. Yeah. So as the scanner runs the probes and gets results, it's compiling that into basically a giant YAML file. Yeah, it's actually more complicated than that. But as it gets results, it's feeding them in to our database, back to our platform. And it does actually take a look and make sure that, like, for some aspects of your scan, like for the authentication portion, we do take extra care to make sure that we're not, if we happen to see any private data such as passwords, for instance, we're not going to send that to the platform at all. So just results like, hey, the SQL injection scanner found a potential SQL injection vulnerability. That's high vulnerability, a high criticality issue. It just sends that result in. It doesn't send anything about your code. It does send the evidence that it found. It sent what it sent in and the evidence that it received back. But any secret data that might be in there, it scrubs.
Yeah, and since it's run locally through that Docker container, that scan is happening on your machine or in your CI/CD pipeline, wherever you're running it. So it's not a SAST scanner that has to send your code up to where the scanner is running. Instead, that scanner is running where you are running your app.
Yep.
All right, we got another one, which is it possible to export the result from StackHawk to another format, for example, serif?
It's funny you should ask that. We are working on that right now. Serif is actually a format for static code analysis, and ours is a dynamic scanner, so it's not going to be able to, for instance, point to the specific file and location in the file where the vulnerability was found. But we're still trying to export into the serif format, and we're going to be adding that to our GitHub Actions action soon.
And we can currently export into JSON. Is that right, Zach, or did I?
I am not sure if we. I'm not sure if we export our full results to JSON, but
okay.
There is a lot of detail about the scan that happens that ends up in the scanner container, and for troubleshooting purposes, we can pull that out and help you with scans.
Stay tuned for that serif update. Sounds like it. Awesome.
Thanks so much, everybody, for coming, and I hope this was helpful and useful for you all. Really appreciate you coming.
Awesome. And if folks start scanning and you run into any problems, I think, Zach, would you mind flipping your contact info up on the screen?
Sure.
So folks know where to reach out. You can find Zach on Twitter or via email, mainly Twitter. And then if you run into any problems, feel free to reach out to us at support@stackhawk.com. That will be answered by a real human promptly. We'll be happy to help you figure out whatever's going on with your scan so you can make sure you're releasing those secure applications. That's everything we have. Thank you all so much. I hope everyone has a great day. And feel free to reach out if you need anything soon.